Welcome. If you're here for the Teaching with Tinkercad webinar series, you are in the right place. We are so excited you're here. And we're going to get warmed up with this activity. So we would like for this to be as much of a two-way conversation as possible. So please let us know in the chat. So the theme this episode is we're going to be talking about fun activities that you can do for Computer Science and Education Week. So we thought we'd kick it off with this question. So what is your first memory involving computer science? I am warning you, you might give your age away as well in answering this question, but I will kick that off by saying the upper right-hand corner is my first memory, which was Logo when I was in first or second grade, maybe third grade. We used Logo with the little turtle, and we made, you could make a square, you could make, I felt very smart when I did a star shape using Logo. I felt like that was advanced math skills. And I was on my way to being a computer programmer. What's your first memory involving computer science? Jenny, you created this beautiful collage. What?
I did. Yeah, a lot of these are part of my childhood memories of working with computer science. The Speak and Spell, Speak and Read, and Speak and Math were all favorites of mine as a kid. We have a couple comments coming in. Punch cards in high school. Children playing Oregon Trail using 5.5-inch floppies. Atari.
Yeah. I was a beast at Oregon Trail.
Basic. Another Oregon Trail. Commodore. Yeah.
Yeah, Atari was definitely my first gaming system. Giving you more clues about how old I am.
Love the Atari. Eliza talking with a computer program. Basic programming in high school, playing Pong on my brother's, I'm not familiar with that, Commodore 64, Logo.
Yeah. That's where the magic happens, Logo. The little turtle too. And just to suspend your belief that that triangle is actually a turtle.
A Tandy computer with a big programming book and a black and white TV. Nice.
Well, now I'm feeling all warm and nostalgic, and I just want to get started. But do please keep warming up the chat. Get to know each other. Introduce yourselves to each other too. So you'll learn in this webinar series that if you're new to Tinkercad, Tinkercad is not just an educational technology. It's also a community of wonderful teachers and all types of makers and creators. So welcome to the Teaching with Tinkercad webinar series. The theme of this episode is Make Code You Can Touch. My name is Kellyanne Mahoney. I'm a youth program specialist at Autodesk. I'm also a national board certified teacher. I taught in the Boston Public Schools for 13 years prior to joining Autodesk. I also want to introduce my trusty sidekick and colleague, Jenny. Jenny, do you want to introduce yourself?
Sure, everyone. I'm Jenny Fennell, and I'm Content Development Manager for Youth here at Autodesk. Thanks for joining us tonight.
Thank you.
Or today, wherever you are.
Wherever you are. This is one thing that we've learned about our audience through this webinar series is it's so cool, and we encourage you to connect with each other in the chat because people are from all different types of places, and there's all different types of things you can learn from them. Also, please, if you want to connect with us, we encourage you to do so. You can even tweet during this episode tonight. You can tag us at Tinkercad, at Instructables, at Autodesk EDU, or you could even use the hashtag #TinkerTogether. I am so excited tonight that we are joined by my friend Diane Brancazio, who is the K-12 Maker Team Leader at MIT Edgerton. So we're going to hear from Diane tonight about some really fun and inspiring activities that you can do with your students for Hour of Code. I'm also so excited that Matthew Dalton is stepping off the treadmill tonight, and he's going to be presenting with us. So he's going to be sharing some how-to resources to get started with Tinkercad Codeblocks. So Matthew is the K-12 Community Manager for Instructables at Autodesk. So how to participate? Again, please talk to each other in the chat. I'm not offended if you're not listening to my presentation, if you're into a cool conversation on the chat. And every once in a while, Jenny will chime in and let us know what you guys are saying in the chat as well. So do please stay engaged either by listening to the presentation or by connecting with others or asking questions as well. Do know that at the end, we have a formal question and answer with all of these beautiful characters from the Tinkercad and education team at Autodesk. But many of these people are actually here right now answering your questions in the chat. So fire away. We do have some goals for this evening. Goals are important. One of them is that we hope that you leave considering why computational design is becoming an essential literacy. We also hope that you learn how students can make their computational thinking visible through analyzing, creating, and remixing interesting algorithm components using Tinkercad Codeblocks. We also hope that tonight you will discover accessible, playful projects just in time for our code that will empower students to see themselves in computer science. And do please stick around at the end for our formal question answer, but do also throughout, if you have any questions, the Tinkercad team and our extended education family, including Instructables, is also here tonight. So before we get started, Daria is going to come to take a pulse of the room. Daria, you ready?
Perfect, yes. So for the next couple of minutes, we'll launch a poll right now, just before we begin, to get a pulse of the room. And what we do with this information is to better figure out how often you use Tinkercad and how we can level this conversation. So right now I'm seeing about half of the folks here to a quarter of the folks are on Tinkercad almost every week. But we've also got a great diversity of those who are completely new to Tinkercad, so welcome to Tinkercad, as well as those who use Tinkercad once a year, once a quarter, a semester, or almost every quarter and semester.
We're very clinical with analyzing data in this webinar as well. So thank you, Dr. Daria, for taking a pulse of the room. All right, so this is the sequence for this evening, and all my puns are intended. So tonight we're going to kick off by exploring the question of why teach computational design to begin with. And then next, we're going to hear from Matthew about how to teach computational design with Tinkercad Codeblocks. Then we're going to hear from Diane, who's going to share more fun hands-on projects from MIT Edgerton. And then finally, we will end with our live question and answer. So to begin, we're going to start with the topic of why teach computational design. But before we do that, if you're new to Tinkercad, which we now know that many of you are, so welcome, this is what the landing page for Tinkercad looks like. Tinkercad is a free, easy-to-use web app that equips the next generation of designers and engineers with the foundational skills for innovation. So this includes 3D design, electronics, and coding. Tinkercad works quite well on Chromebooks. It works on iPads. One of the really fun features of using Tinkercad on an iPad is that students can unleash their designs into the real world using augmented reality. So that is in the Tinkercad iPad app. So this is basically, if you're in the 3D editor in Tinkercad, what it looks like. You're just combining shapes to make more complex shapes. You might increase that complexity by subtracting from the shapes. You might then export whatever your design is as an STL file and 3D print it. But we're going to learn tonight there are many ways that you can help your students make their thinking and their ideas visible through using Tinkercad and other ways of fabricating. So Tinkercad Codeblocks is another environment in Tinkercad. So you can see that you can make really complex computational designs. But you also can just start from scratch. The blocks that we use actually are very similar to the blocks you might be familiar with Scratch. And there are some starter activities, as you're seeing here, that will help you learn through trial and error, which is something that's really important in coding and teaching computational thinking. So during our last episode, Jenny actually introduced this really cool definition of 3D digital literacy and design, and introduce these 3 pillars to this concept, which is design and make innovation, spatial reasoning, and computational design. So tonight, we're going to focus primarily on computational design, where you are using algorithms to explore complex creative ideas and communicate through digital expression. So to decompose this concept even further, or to break it down, computational thinking involves these 3 ways of thinking. So decomposition, abstraction, pattern recognition, and algorithms. So tonight we're going to be talking about how you can kind of take all of that sort of ways of thinking, and it sounds kind of abstract, and think about how you can make it more concrete for students by making code you can touch. This might also involve the concept of embodied cognition, which is the idea that the more you touch something, the more you learn it. We were inspired for the theme of this episode by our teacher friend, Mr. Rob Morrill, and his, it was actually, he coined the phrase, make code you can touch, but he also has this really great section on his website for code blocks, and it shows all the different ways of making that you can do with code blocks. So you could, 3D print students' designs, you could use a die cut machine to make greeting cards, you could do iron-on t-shirts. So there's all types of ways that you can make code that students can touch, or they can make code that they can touch. Another great example is from our friend, Mr. Stephen Jones. He created this lesson plan on Tinkercad. I'm going to show it to you in a moment, but pattern recognition, really important concept in computational thinking. And how cool is it to kind of combine that with the concept of biomimicry and to think about how you can recognize patterns in nature as well. It's another way into teaching computational design and thinking for students. So this is what his lesson plan looks like. So if you go to the Tinkercad Teach page and you click the Explore Lesson Plans button, you'll see all of these really fun projects that were designed for teachers, by teachers, including Mr. Stephen Jones, who made this awesome lesson that is aligned with learning objectives, standards, so ISTE standards, Common Core standards, I think are there. These lesson plans are media rich, so you'll see, all the different resources that Mr. Jones included, including a PowerPoint. So it's really it's very plug and play, easy to do. He's even provided you with scripts for programs for how to create some of these designs. Oops. And in addition to that, he links out to his Tinkercad Codeblocks designs as well. So it can help your students think about how they can even reverse engineer some of those designs too. So decomposition, again, is a really important component to computational thinking. That's how we learn. So coding and design are very similar in their processes in that they are iterative. So you are coming up with an idea, you're trying it out, you're running it, you're testing it, you're reviewing it, you're improving it. And the interesting thing about design and computational thinking or coding is that they are starting to more and more converge with one another. And one of the reasons for that is artificial intelligence is increasingly being used as a design partner. So that's one of the things that we're going to be talking about tonight, how it is transforming the future of making into a collaborative exercise between digitally generated solutions and human imagination and curation. And a really cool concept that is related to that is the concept of generative design. And tonight, Matthew is actually going to show you a code blocks design that is kind of like a baby step into understanding kind of the key concepts of generative design, which I'm just going to review with you really quickly. So generative design is a step-by-step process. You can actually access generative design in Fusion 360, which is a program that we talked about in our last episode. So the first step in generative design is you are generating ideas of goals. So sometimes when you are starting out in a design, you might not know what the solution is to the problem, but you might know the requirements that you need in order to solve the problem. So as you can see here, and this is supposed to be a GIF that's running, but it's okay. But as you can see here, in this design, there are a lot of goals that are along the edges, and also there are parameters, so ways of measuring those goals. And what you do is you are combining, so you're partnering with an algorithm in order to come up with a bunch of different solutions. The next step is to analyze. So you've plugged those goals and those parameters into the program, and the program is running it, and it's generating hundreds or even thousands of different potential solutions to your problem. The next step is to rank. So you're going back. So after you've analyzed and you've seen all those many different iterations and possible solutions provided by the algorithm, You are, as the editor, the curator, the designer, the engineer, you are pushing aside that algorithm for a second. You are stepping in and you're reassessing your goals. So you might decide that, I'm just going to focus on these top 3 goals of daylight, low visual distraction, and views to outside, and get rid of the other ones, and then run it through the program again. And that's how your design evolves. So, even though you are kind of refining your goals, it's still an iterative process, because now you're seeing what the outcomes are after you've kind of changed the inputs of it. So this is an exploration process. So even though you've refined your goals, you still might end up with a lot of different potential solutions, and you need to, ultimately choose one as a result of that exploration. And the last step to this process that you might iterate again is to integrate. So when you are using generative design, you don't need to generatively design a whole car or a whole building. It could just be a little piece of that building or a little piece of that car. For example, this is a seat bracket for a car. But you might learn from that process and then think about how you could apply it to other parts of the vehicle. Or you might use generative design to think about what is the best manufacturing process to create that design with. You might also think about how you could partner with artificial intelligence again, and think about ways that you could, run a simulation on wind or on noise, and think about how you could change your design. So teaching students computational thinking and introducing kind of some of these concepts to students can also lead to really interesting big questions that they can explore, they can debate, they can internalize, and it can help them start to see themselves in STEM and see themselves in computer science. So big questions like, can automation solve the housing crisis? Or can collaborating with algorithms make us more creative? We actually did this. So this is one of the last big events that we had at the office in Boston prior to COVID. We invited from Brighton High School, their Spanish language debate team. And they were really interested in the topic of automation and how automation could help the issues of affordable housing and also disaster relief. So we had a debate at the office. So this is one of the students who participated in the debate. And he said, I think the debate helped me think about the environment. The efficiency will help cut down on pollution. It also made me realize that I may be interested in different parts of a particular job. In other words, I was not forced to think of one job as being very limited. So thinking about how students can, connect with their learning in school to the future of work. This is another student, Valeria.
Hi, so what's your name?
My name is Valeria. I'm from Brighton High School.
Okay, and you went to the debate at Autodesk, correct?
Yes.
Okay, so my question is, how did the debate impact your thinking about automation in general?
So I think with that topic that we discussed in the round that we had on the Autodesk, so I think changed my mind in terms of thinking more deeply about how the technology impact our life. And I feel like thinking about jobs and people losing their jobs by that is an important issue. It's not just talking about how technology would help, but it's also what would happen if we do that, what would be the consequences to do that.
Okay, thank you so much, Valeria.
Thank you.
And I love ending my segment with a brilliant student. So, so before we move on to Matthew's presentation, we wanted to push out this question to you. So, thinking about how these students are thinking about solving problems through, collaborating with automated processes and designing with code. What role can designing with code play in your students' problem-solving projects? So please let us know in the chat. Jenny, how's it going in the chat? It seems to be lighting up.
Oh yeah, there's a lot of conversation going on. There's some questions about the innovator kits, I think.
Those are quite popular.
Very popular. Yeah, what role can designing with code play in your students' problem solving? I'm just waiting for some responses to.
It's kind of a deep thoughts question, so we might go back to this one a little bit later. Because I do not want to hold off on Matthew's presentation because I'm so excited about it. So Matthew is going to be talking about how to teach computational design with Tinkercad Codeblocks. Matthew, take it away.
Although you might notice me moving around a little bit. I am on a treadmill. I have slowed it down so I can just go on a relaxing walk with you as I talk. So it helps me concentrate and focus. So thank you for bearing with me. Prior to working at Autodesk, I was a makerspace educator and STEAM integrator at a private K-8 school. And Tinkercad was one of the many tools I kept at my disposal, and one that repeatedly got used by both me and my students. Next slide. Another tool I used a lot was Instructables. It was incredibly useful because there's tons of project ideas there created by a passionate community, all with step-by-step instructions and photos, sometimes videos and additional downloadable stuff. All of the Instructables I'm going to show here were created by teachers, and many include learning goals, handouts, and show how those teachers implemented that project into their classroom. You are going to get this presentation later, so you'll have all of those links in the presentation. One thing I found when I was teaching students to code, the first major hurdle was always algorithmic thinking. Not Tasha, a teacher on Instructables, shared a project she created where students had to use a preset list of commands to program her to give each of them a cookie. And I think this is a super fun activity to learn about how computers follow directions, and you can do it without ever pulling out a computer. Next slide. And once students are comfortable with algorithmic thinking, a great next step is block-based coding. It's easy to understand and build with blocks, to build code with blocks, and it provides a simple springboard to text-based code design. Next slide. One great way to start the transition from block to text-based code is viewing that code side by side. And while you can't do this in code blocks, Tinkercad Circuits does offer this feature with both Arduino and microbit code. So you can just see it in the image, just right side by side, the block, and exactly what it's doing in the text code. Next slide, please. So why use code when designing in 3D? Well, there are several reasons. Next slide. The visual code progression allows you to watch the code run one line at a time. And by adjusting the speed or stepping through lines manually, you can quickly iterate and troubleshoot designs. Using variables allows you to build connections within your code or to real world data, which I'll show examples of in a bit. By using loops, you can bypass repetitive modeling tasks. And finally, I really like using the example shown here because I think it's important to point out that code doesn't need to be difficult. This simple series of 3 shapes and 3 moves creates a rocket ship. And that's kind of what Codeblocks does and how it inspires. Next slide. So I want to take a few minutes to introduce you to the Codeblocks environment with a video I made based off of this Instructables project that I really enjoy. And the project asks students to look for and recreate patterns found in nature. Next slide. So the video starts logged in to the Tinkercad dashboard. I click, So I'm going to click into Codeblocks and then create a new code block. And then a pop-up, I can pick starter designs or just continue with the blank project space. And then once in the editor, you'll notice 3 columns. I grab the sphere out of the blocks panel, place it into the blocks editor, adjust the panel layout to be more comfortable, and then run the code to test it in the 3D viewer. Clicking the arrow on the sphere allows me to expand that block out to show more attributes. I made the radius smaller, ran the code again. And the goal of this project is to create a pattern. So I grab the count block, which will loop between sets of numbers and generates a value based on where you are in that loop. And then I added a move block because, the video's having trouble. Because I want to use the count to define the y-axis. And then I run a quick test to make sure everything's moving kind of in a general direction that I want it to go. The final part of this loop, and in this you can see that I use that count variable, the I plus 5, to kind of control where it's going. And then the final part of this loop is the rotate block, which needs a bit of math. And you can see me kind of putting that together right now. The equation I use is just pi times and then count minus 1, since count starts at 1. So it'll basically count from 0 up to whatever the count set to. And this will change the Z rotation based on that count every cycle of the loop. So I put this code together, and the way the math works in Tinkercad is each of these blocks has like 2 values and then the operand in the middle, and those sets are basically in parentheses. So I put it in there, I run it again, nothing changes. And it didn't change because the pivot point is based on the sphere. So I changed you can see changing the pivot point there to make it based on the work plane and centered on that work plane. So then it circles around the work plane instead of based on a specific point. I adjust and it starts working. So I adjust the count up to 90 and make sure it still works with a higher count value. So now I can see it's working, and I've already got this really cool shape with just these 4 lines of code. So I add a couple more variables. That bottom variable is called angle and the top variable is called pi. I move the math that I had done earlier up into the pi variable, and then I move angle down into the what was in the access. And now I can easily switch out what value angle is pointing to. Right now it's pointing to pi, but now I'm going to create a new value called golden ratio, because I want to be able to quickly switch through different equations and kind of see what changes in this and what updates. And I can quickly iterate and quickly kind of decide what happens. And by changing the counts, right now it's going from 1 to 90 by 5s. I could change it to go by 1s, and it will count 1 at a time. I could change it to 10, and it'll count every 10th digit between 1 and 90. I could change it from 1 to 20 and count it by 0.1. So I have a lot of ways to kind of iterate this and see different ways of displaying this. And so long as I stick within the, it can only display, each 3D shape is called a primitive, and it can only really show 200 at a time. It can only build 200 at a time right now. So as long as I make sure that my count doesn't go, or the number of primitives that get shown isn't more than 200, there will never be an issue with what I'm doing here. And I can write as much code as I want, make it as complex as I want, and then quickly kind of go through. And you can see, like, it's taken me 5 minutes. I sped the video up a little bit, so I think it originally took about 6 minutes. And then I have this quick way, and you see me now just kind of iterating through these different designs and different values just based off of those two, just the pi and the golden ratio. And I can quickly kind of look at all these different things. And that's what Codeblocks does for you. It allows you to do these really quick, next slide, really quick kind of views at what you can do. And this is another example. And before I jump to my next video, I want to show you some examples of how I've seen teachers utilize Codeblocks in their class for a variety of different subjects. And this is an example I kind of showed you briefly, the starter designs in Codeblocks. And by simply changing one variable in this, you can modify how many hexagons are used to build this basket. You can also quickly modify how many sides the polygon has, which axis it rotates around, in addition to a multitude of other things. Just everything that this is based on, you can change. Next slide. So More Than Some is a teacher who created this fidget gyro keychain project as a way to introduce his students to Codeblocks. And it's just a really cool project that kind of onboards students. Next slide. He then shows them how to export their designs into Tinkercad's 3D editor so they can personalize the center of their gyro fidget for themselves. Next slide. This is another great example that showcases the simplicity of code and kind of the removal of repetition from a project. By creating a connected base pair, then just repeatedly copying and applying the same move and rotate variables, you can quickly create a simple strand of DNA. Next slide. Alternatively, you can get a lot more complex. I've seen a lot of solar system models created in Tinkercad and was curious if it would be possible to create a scaled version using Codeblocks. Next slide. So I found multiple data sets for the planets in our solar system, including the diameters, mean orbit distances, eccentricities, inclinations, longitude of ascending nodes, because I wanted to try to incorporate this into the design. And I mapped all of the diameters and distances to a number line that was usable in Tinkercad. I taught myself some trig to adjust the planets' orbits and angles. And then in the process, learned a ton about the planets that I wasn't aware of. Next slide. And in the end, I was able to create a scaled, though not to scale, version of the solar system, which even now I'm hugely proud of. And since I've done this, I've been messing around from time to time, trying to figure out how I might be able to create a to-scale version by really utilizing the scale block, which allows you to kind of scale apart larger and smaller. Next slide. In this example, a teacher asked students to look at architecture, breaking it down to its core components, and then building it back up utilizing those basic building blocks. Next slide. This project also expressly reinforces using variables and loops when coding. Next slide. This teacher creates a mold for students, or creates a mold of 3D students, oh, not 3D students, creates a mold of students' 3D printed objects using a food safe silicone, then creates cast of those molds using chocolate. Next slide. Wait, go back one. There it is. And this is a project that I taught to a middle school class, and it went really well. Students were given a badge template in Codeblocks and asked to design their own badge. This allowed for a lot of creative freedom and personalization on the students' part, while keeping the finished badge within a predetermined print size. Next slide. So with that, I want to jump into one final video based off of this random snowflake ornament project to show a few additional points. Next slide. So in this, I want to show you the Instructable. So this is the random snowflake ornaments Instructable, and you can see it has all the details about the project, why it's coded a certain way, how to implement things, everything you need to know. It includes a link out to the Tinkercad project. You click copy and tinker, and it puts the code into your account. So now you have it, you can mess with it however you like. And you can see this is complex. It's got a lot of code, it's got a lot of stuff going on. I adjust my workspace to make it a little easier for me to use. And I just start running the code to see what it does. I speed it up, I run it, I adjust my plane so I can kind of see what's going on. And I just want to see how random it is. And I'm like, it's very interesting. And so looking at the code, those second three variables, main arm length, the width, and the size, the hexagon size, all have a random value attached to them. And so by going in and adjusting this random value, I can set how big or small I want this variable to be between. And Kellyanne mentioned generative design earlier, and this is kind of that generative design light, that kind of intro of like, hey, this design changes based off of these three variables right here. And changing these variables, you have a lot of kind of say in what happens in this design and how crazy it can get. And I think that's kind of awesome. And that is all I have.
Well, I think that you are awesome. And I also think that I just taught myself some trig is one of the reasons why I love working with you. So awesome job, Matthew. I always learn so much from you. So our question to close out this awesome segment by Matthew is, what is a fun computer science activity you have done in the past with students? Or if you haven't, what's something you might want to try? Jenny, what's happening in the chat?
A lot of people are asking about links, so I want to just remind everyone that we will be sending out a link to the slideshow as well as a link to the recorded webinar to everyone who's signed up. So don't worry, you'll have links to everything that we're showing you here today. A couple of people have mentioned doing the snowflakes activity. My fourth graders love designing bubble wands. It's a fun computer science activity. Someone would like to try the solar system project with their students.
So cool.
Yeah, we have pencil toppers, another vote for bubble wands, picnic tables, so we could design awnings for them. That's cool.
Oh, that's a really cool idea.
Yeah, micro pets with craft supplies, fidget spinners and snowflake ornaments.
And I love thinking about how to make, bring your coded design to life, to think about ways that you can incorporate different types of media as well. So not just 3D printing, maybe, including craft supplies, maybe coloring. I think Diane is going to be a fountain of inspiration for some of those ideas too. So please keep letting us know what you're doing, and more importantly, let each other know, inspire each other in the chat. But you are about to be very inspired by our friend Diane from the Edgerton Center. So she's going to talk about more fun hands-on projects from MIT Edgerton. Diane, take it away. Diane, you may be on mute.
Now, can you hear me?
We can hear you now, Diane.
All right.
All the way from MIT, too.
Yes. Hi, guys. I'm Diane Brancazio. I work at the MIT Edgerton Center, which has been a home for experiential learning for decades. My background is the lab that's across the hall from me, but there's a bunch of students in there working on stuff right now. And so we all have to wear masks. So I'd rather be here and not have to have my mask on. But the Edgerton Center is a home for the student clubs and teams. And you can see in my slide, the motorsports team. We have a makerspace for students working on school or personal projects. And that's sort of like what I have behind me. And you can see some of the students in one of the pictures there. And we have regular student visits from local schools. So it's like 4th to 6th grade. And last but not least, we have K-12 Maker program, which I lead, where we do professional development for K-12 teachers that want to bring all things maker into their schools. I've been working here for about 6 years after 15 years of teaching in public middle and high schools, and taught mostly technology, engineering, computer science. And before that, I was a mechanical engineer in consulting. But here's the important part. I came to MIT to work on summer STEM programs for summer camps, and wrote courses in 3D printing, electronics, and app inventor. I made sure they all had design at the center, because it's not really about the tools, it's about the design. But I soon got involved in the maker movement. And as a teacher, I knew there's a lot of issues right now with engagement in schools and empowerment of the students. And I set out to help teachers in traditional schools bring cool tools and making into their regular academic classes. Because I want all students to have access to new technologies, not just the ones who can go to the summer camps. So that's kind of where I'm coming from. Now we can do the next slide. This is a project I work on at the Sailing Center, community boating over by me. And it's called RoboSail, where the students are going to create an autonomous sailboat step by step. But what Matt mentioned was algorithms. And it's a big word that not everybody knows they have, but we all have them. And sailors know how to sail upwind, how to sail downwind, how to do a tack or jibe. So can we get those algorithms into the boat? Can we trim the sail right? Can we do all that? The answer is yes. And we can do that from like 8th grade on. So that's the RoboSail program. But let's go to the next slide. Okay, so where I'm coming from, the big picture in school is to educate students to be self-directed, creative problem solvers, and they can choose the right tools for the challenge. And as teachers, our job is to help them discover resources and technologies, build their skills, and learn to love learning. And so a good tool for that, computers and microcontrollers, they're great tools. But coding is a useful skill that's still not regularly included in the school curriculum. So we've got CS Ed Week, we've got Hour of Code. So bring coding into your class during this week, do an hour of code. So now you can get away with putting code into your class and say that it's the right thing to do. Okay, this is a class right now that I did over last winter remotely, completely with students. We're building pinball machines that we designed here. They can be single or dual player. And this is one that a friend of mine put together, and just wanted to show some of the opportunities for coding in a pinball game. Where'd the sound go? So here we're using NeoPixels and a lot of other switches. This program used Scratch, but we are also doing it with Arduino and Microbit, finding ways to build a pinball machine and add the sound to it and the lights. Let's go to the next slide. Oh, okay. So we have an Instructables page with, it says 15 Instructables, but as of yesterday, it's 16 because we have a new one on it. There's a lot of Tinkercad projects on here, but there's also a whole bunch of electronics ones as well, and a few laser cuts. So let's see what they are. Okay, so I saw the random snowflake generator, and I wanted to make it simpler and accessible, I don't know, or no, appropriate for holidays other than snowy holidays. So I think we're going to show the code for this, Kellyanne, right? Okay, so the code here just basically says you're going to make a pedal, but we start by saying you got to know a little bit about the Tinkercad environment. So you have to know where the origin is. So what does that mean? And how do I make a pedal? I have to start with a cylinder and scale it. I go into having variables. I make the pedals all in a nice repeat loop. I add the center, and then I've made it so I can make the center on another piece too. So I can make my multicolored daisies like I show here. Can put magnets on them and put them up on the whiteboard. So if you go to any of our Instructables, you can find out more about what we do because it is at the bottom. And the last slide did have the link to our Instructables page. It's just Edgerton Center, all one word, can help you find it. Now here's another one we have on. We have a few on it, and they're really set up to be like lessons. You could use them as a teacher in a classroom. You could probably follow it if you're homeschooling. And this one here, we did the Code a Charm bracelet. So I'm wearing one, which I cannot take off because I've done that. I also have lots of Tinkercad made bracelets on. This was a voting one. Here's more of our projects. I have snap rings, which are kind of fun. I've got one for the Senate and the House, trying to choose which one of those I want to be part of, if any. But in this Instructable, and I'm showing you the outline of the steps. In the first step, we spend some time talking about the coordinate environment, where things come in, and we go through each one, moving, scaling, rotating, grouping, and working with variables before the lesson starts. So that's now a glossary that you can go back to. And in these particular lessons, you add maybe 3 or 4 lines of code at a time. You're not adding a huge block that you're just sort of dumping in. And all of these are sort of a set thing, but you can change them. You can do that round circle, or I just changed the circle into a heart, and I was able to do it like that. This is these are all articulated, meaning that you just take them out of the 3D printer and they're ready to go. I'm in the wrong my window here. Let's do the next slide. Okay, this is the wiggly snake, also articulated. And this was all backwards design. You find other articulated things on Thingiverse or somewhere, you look at them, and then you teach your code to do it. So you can actually see what's all going on in there because we've coded it. And what's fun about the bracelet and the snake is you set the number of pieces, number of links in it. I could have done it with 2 links. I could do it with 6. Where I run into that trouble is the 200 limit on the number of pieces that I can do in Codeblocks. And I'm showing one there that I can put little spots on the back too. Okay, let's go to the next one. This is a new one. This is not an Instructable yet, but there's the code. What we like about this, and my colleague Justin just made this, so yay, Justin. It's a ornament generator with different pieces. Now I'm showing there the repeat blocks. So there's like 5 different shapes. And if you set the repeat to 0, it doesn't run it. If you set it to 1, it does. So that's our way of getting an if statement into Codeblocks, sort of an if statement. It allows me to have a switch, turn it on or turn it off. That's the way that I've been using to comment out code. If I don't want it to do a section of code, I could just put it in a repeat 0 times block so I don't lose my code. But here at the top, I show what happens when I use a heart shape, and then next, what happens when I use a star. And if you leave the repeat 1 time on both of them, you break the code, which is really fun to see because nothing actually got hurt, but that bottom piece shows what happened when I turned 2 of them on at once. So it's nice to see how you can just sort of make mistakes and just keep going. All right. These are, so we've been doing starter projects. These are great ways for students and teachers and families to get familiar with the Makerspace, learn how to use Maker tools. So we've been doing a bunch on Tinkercad. We've been doing ornaments and then this little light up thing with tea lights. Just this time of year, people are finding this fun. And next slide. And sort of once you get started doing that, you can't stop. So I have on more bracelets. Those are laser cut acrylic, heat formed to make it. And the other ones are cut on a vinyl cutter, just having some fun. Basically, tea lights are great ways to do things this time of year. They're pretty inexpensive and we can light lots of things up during this dark time. Let's see if we have one more slide. Oh, no, that's just it. We think maker learning experience are really important. They're creative, hands-on projects with cool tools, STEAM elements. And at our lab, we support educators who want to inspire and engage students by integrating Maker into their regular academic curriculum. Find all sorts of resources on our website, k12maker.mit.edu. That's just a list of some of the stuff we have there for free. We also offer teacher professional development, but there's an awful lot of stuff right there on the website. So thanks for letting me share.
I'm super jealous of your bling, Diane. But also,
yes,
also
my bling.
like you're
Plastic bling all over me.
I was a recipient of your bling, so I do appreciate that. And we appreciate you, and I feel like I want to go out and play with code now too and make something cool. So thank you so much, Diane. And Diane will be here for the question and answer as well. So before we move into that though, we have a question for you. So Diane definitely, I think, exuded her love of coding. What do you love about coding? And how do you want to bring coding into your classroom? Jenny, how is it going in the chat?
And great, people sharing resources. We've got a lot of links going back and forth. Yeah, we just posted a link to the ornament generator Diane was showing. Okay, here's one response to the question. I love seeing my students take their thoughts and stories and making them come alive through their code. It makes it real for others to see.
It is really fun to think of coding as a way of storytelling as well. And we oftentimes think about with Tinkercad that it's also a great storytelling tool just generally.
Mm-hmm. And coding allows immediate iteration. You can see the change quickly. Very true.
Mm-hmm. And if you make a mistake, you notice it really quickly and you can just figure out how to fix it.
Yeah. I love how code is almost limitless with possibilities.
Mm-hmm. It's an interesting balance of constraints and possibilities that are endless.
I love the challenge it is for me and how much the students teach me and others. That's very true. We can learn a lot from the students.
It's a way for students to show perseverance, I think. It's sometimes, I think, surprising how it kind of brings that spirit out in students that maybe don't show it in other ways. Like I used to teach English, but sometimes I would also bring computer science into it. And it's just kind of interesting to see how that perseverance translates across different activities. So before we move into our announcements and our question and answer, I think Daria wants to check in another time. So Daria, take it away.
Perfect. And we launched just another poll to figure out after today, how likely are you to try something new that you learned in today's webinar? The options are you're very likely, somewhat likely, not sure, unlikely, and very unlikely. And this is just so we can better calibrate what we talk about, the pace at which we talk about it, and also our follow-up materials that you'll get next week. So I'm seeing some great responses. Vast majority of people saying they're very likely to try something new from today. So that is fantastic feedback to hear. I'll keep the poll on just for a little bit more for everyone to get in their results, but Kellyanne, let's keep going.
Very cool. All right, I think Daria has an announcement as well.
Yes. And so earlier, I think Tracy Zhang was asking in the chat when we first started, is there a way for us to send our circuits designs into Fusion 360? And the answer is that was a very prescient question. As of next week, we will be announcing a very exciting update for Send to Fusion for Electronics. And so that means you can get started within Tinkercad, design your circuits, design your schematic, and send your view only schematic into Fusion 360, where all the components are already mapped into the existing Fusion 360 library. So we're very excited about this release because it's a really powerful way to get started with electronics and circuitry in a really low barrier, fun way, but also move your designs once you're ready into a professional tool to rotate, mill, get your board made. So we're very excited. Please stay tuned. That announcement will be coming this Monday.
Thank you for sharing that scoop with us, Daria, as well. So Daria is taking off her clinical hat into her reporter on the street hat. So thank you so much. The Tinkercad webinars are a great source of Tinkercad news. Another announcement I think we've been making, but I want to clarify that if you're watching this live, next week is Computer Science and Education Week. So this slide actually links out to some sources on Computer Science and Education Week, and also Hour of Code. So it's next week, and Jenny actually put together this awesome collection of Tinkercad Codeblocks and Hour of Code activities on Instructables, including Diane's Daisy generator as well, and some of the other ones that Matthew talked about. So this is linked to the slides as well. We also have another announcement from Instructables in which we will be launching an Hour of Code, or is it already launched? Hour of Code Speed Challenge. So do please check that out as well. It is a fun contest. And do please stay connected with us. So these are all the different ways that you can stay connected. And if you have questions after this webinar series, you can also email our episode. You can email tinkercadlearning@autodesk.com. But there's all, we're on Instagram, we're on Facebook. We have a Tinkercad blog. So check it out. And before we move into our question and answer, I just want to let you know that in addition to being emailed these slides, you also will be sent an email with a link to a folder that includes these slides and also a certificate for hanging out with us tonight. We hope that it was an enjoyable way to earn a certificate. So here's another question that you can consider in the chat. So what kind of support would you like from Tinkercad to help you use code blocks with students? This might also be, something that you could bring up in the question and answer as well. So we are going to move on to our question and answer. I'm going to stop sharing my slides, and we're here. So Jenny, any questions for the big group?
Yeah, a question that just came up is Fusion 360 only for high school? So the answer to that is you need to be 13 and above to use Fusion. Does anyone add any detail to that?
Yeah, absolutely. I think it's not just for high school, it's used by professionals in industry. And so that's the really exciting part. Unfortunately, it is limited to those who are 13 and over around the world, and 14 and over if you're coming from China or South Korea. And that's just due to COPPA and making sure that we're compliant there with student data privacy.
Mm-hmm. And we had a participant ask about whether we have classes in Spanish or with translation. Although we don't currently offer that, is a great suggestion and something that we're looking into, translating a lot of our materials into other languages. There is a toggle at the bottom of Tinkercad where you can refresh your language choice, but not all of our materials are translated at this time, but we are looking into doing that. We have a couple suggestions for some things that I'm because they're working on. We had someone ask about a glossary, like a go-to glossary, and that is something that we are working on providing. A quick reference guide for the blocks, as well as designing in Tinkercad. We do have a quick reference guide available. I posted it. I answered one of the questions in the Q&A I'll see if I can also post that in the chat. I'll do that right now so everyone can have that. And let's see what else is coming in. It would be great to have objects snap in Tinkercad. Does anyone want to talk about that?
I'll say there's a couple of, I don't know what you want to call them, workarounds, but you can use the work plane tool if you're in the 3D editor to just snap, to basically make a work plane directly on an object. You can also adjust how much it moves based off of the arrow keys. So if you only want to move it like just 0.5 inches at a time or 1 millimeter at a time, you can set that and then use the arrow keys to dictate exactly how far it moves. So those are a couple of ways you might be able to do that.
Okay. And we had a request to see guides and downloadable PDF format to assist teaching a classroom of students. So thank you for that suggestion. That's a great idea. We'll try to provide more of. I'm trying to see if there's any other outstanding questions here that we haven't addressed yet. This is the chance to ask.
I know the team was pretty busy answering Q&A just throughout the webinar. Are there any questions that other folks would benefit just from hearing live for those who are viewing the recording later on?
Sure. Well, a number of people ask about specific links, and I did provide those in the Q&A. And just a reminder, we will be sharing the presentation with everyone afterwards by early next week. A couple people ask about places to get started for basics, and we provided links to that. I'm just going through here. There's a question. Right now I use Scratch for the kids to create the circuit and then copy and paste the code into Tinkercad circuits to see the simulator in action. Are you working on adding visual coding for circuits too? And same as code blocks. And Christian, did you want to summarize?
Yeah, well, I can. The answer is it's there right now. If you are working with a microbit or an Arduino in Tinkercad circuits, there are the code blocks, kind of like what Matt was showing and what you've seen throughout this webinar. They work, and you can basically build your code with the code blocks. And one differentiator is that you can actually see the actual text code being built as you snap the blocks together. So it's pretty cool, and I recommend it to check it out. There's a bunch of starters in the circuits editor where you can just drag a pre-built, say a microbit that's functioning, and you can see how it all works together.
Okay, I'm just scrolling through to see there. Oh yeah, there was a question about student privacy that came up, and I know that's a common question that arises. And we do have a privacy statement on the Autodesk website, and that is, Christian, it looks like you answered that in the Q&A.
Yeah, you know, it should be reflected in the Tinkercad Classrooms is a really nice, easy way to get students onboarded quickly without needing to create accounts. And we covered that in our first episode of this series. If you want to follow that, you can probably get more information from that episode.
Tinkercad YouTube playlist for the series.
Yes.
You can binge watch over the holidays.
There's another question that just came up. Are there any plans on having an offline counterpart of Tinkercad, especially in countries where internet connectivity is a challenge?
Oh, we're right now, Tinkercad requires a internet connection. And the reason is that we can bring this service to so many different types of computers and devices, and there's no real, sort of limit based on what your computer capability is. The capability requirement is that it's connected to the internet. So that's sort of a trade-off. You can do a lot of complex computational things in the 3D editor and in the circuits editor, as long as you're connected to the internet. We are investigating ways to do some things offline. So for example, if your internet fails, or if you need to turn it off for a while and then reconnect later and update. So we're investigating ways to do that, those kinds of things.
I don't see any additional questions. This is the time to ask. Oh, wait a minute. There's a couple that just came in, I think. If we are planning a lesson, can we contact someone with specific questions? I believe the best way to get in touch with us would be the Tinkercad Learning at autodesk.com account. Is that correct, Matthew?
Yes, and I just put it in the chat.
Oh, you did. Good. There you are. Okay.
Racing to keep up with you.
Okay. Yep. I just thought I'd ask some of these for the benefit of everyone listening. Okay. I don't see any other new questions at this time.
Shocked that we are ending on time.
Ah, look at that, right on time.
Oh, weird. Oh, sorry, Jenny.
There's one more. There's one more. Okay. Clever. Can it be integrated with Clever for login or classroom creation?
It's up to the school district, right, to integrate it with Clever, right? Looking at Christian.
Oh, yeah, we won't do it on our side. I think there are ways to we do have like a very convenient way, which a lot of our users are using, is to sign in with Google, which a lot of schools have implemented, and they just put that on their Clever page. And it seems to be a nice shortcut. We don't have a sign in with Clever option in our Autodesk options. Someday we may, but not in the near term.
Well, I'm still shocked that we are ending almost on time. And I just want to thank everyone that came tonight. Participants, I know that this is a busy time of year for you. I mean, it's always a busy time of year, and I know this year is particularly busy. So we really hope that you have a wonderful holiday season. For those of you who are watching this on YouTube, we hope that you continue to have a great holiday season, or had a great holiday season. And do know that this is the third episode in the series. So, you know, if you missed the first two, you can go back to the YouTube and check out the playlist. I feel like I'm trying to make this go over, so so I think we're going to sign off for now. I want to also thank Diane from MIT Edgerton for enlightening us and inspiring us in this holiday season to go out and create something and make something cool. And also to thank Matthew, who probably still won the chat tonight, in addition to giving a really awesome presentation. So I am feeling grateful to be surrounded by such a wonderful team, and that is surrounded by a wonderful community of educators and makers and creators.